We all know how trifling the size and the weight of a grain of sand is, right? But what if I told you that in hypothesis, this very grain of sand would suffice to annihilate a city comparable to that of ours in just seconds? It sounds inconceivable, right? Perhaps the most influential and eminent scientist ever, Albert Einstein, rendered this reasoning possible and feasible with his infamous equation of E equals mc squared, and this led to unprecedented deviances over the course of world history. Einstein first initially came up with this idea when he was working as a clerk in the Swiss patent office in 1905. He had published already 4 watershed papers, one of them being, does the inertia of a body depend on its energy content? Within this paper, he had concluded that if an unit of a body emits an energy in the form of radiation, its mass is decreased by this delta M amount. However, later he realized that this could be more refined. If we think that the energy that is emitted in the form of radiation is just a change of its internal energy, then if we multiply both sides with c squared, which is the speed of light in the vacuum, the equation gets to the form of delta E is equal to delta M times c squared. However, afterwards there is one last remaining step. As we see, c is just number. It's 2 to the 10 to the power of 8 kilometers per second. If that's just a constant number, if their deltas, if their chains are dependent on each other linearly, then on their own they are also dependent in such way. Here, E is the stored energy of the resting unit, which means that if in case one unit is deduced, has lost its energy, has lost its mass all of a sudden, it will emit this much energy.
In the upper right. Upper right.
You see upper right corner. You need to tap on it. Then this card. Yes.
Then this equation started to be utilized in the nuclear field. As we know, the nuclear reactions utilize something called nuclear fission, which uranium is a crucial part of. In this procedure, in so doing, uranium gets up to the speeds of 1 to the 5% of the speed of light. It's really something hefty. And as we talked about, the previous equation was accounting for the objects that were resting. But now, in the nuclear domain, the particles are moving. This is when the Fermat steps in. It relates the speed of a particle with the speed of light. So if the uranium particle was moving with the 1 to 5 threshold of the speed of the light, this would output to this much mc squared, which will still lead to a hefty amount, as mc squared is also a hefty amount. Then this trait of the nuclear fission was also present in the bombardments of Hiroshima and Nagasaki in 1945 by United States of America and Japan, which led to the deaths more than 200,000 and left an ineffaceable, horrendous mark on the following generations as well. The head scientist of the project of the advent of the first nuclear bomb, as we all are acquainted with, Robert Oppenheimer stated, start of the quote, "Now I become death, the destroyer of the worlds," end of quote, which is an epitome of the guilt that he possesses after accompanied with after giving contributions to the advent of such a devilly thing. So, in a sense, I would like to state that if we just take a look at our neighborhoods, what's happening in Iran is a direct result of their insistences on possessing nuclear bombs, which suggests that the effects of this equation still holds and which most probably will hold. So I invite you to be cautious trying to invent new formulas. Thank you.